No, sir.
Okay. So if there's no question, today we can start what you call the random class. A random is a class that allows us to generate some random numbers. And the numbers that are random are what you call unbiased, because there is no any bias of generating any random number, because any number has equally a likely chance of being generated. That is why we said it's unbiased. So if you have 1 to 10, let's say we want to generate random numbers from 1 to 10. So the 1 and between the 1 and 10, any number has an equal chance of being generated. That is why we said it's unbiased, which allows also, which is used in many of the statistical concepts. For any unbiased thing, you can use a random number to generate and use it for any kind of simulation. Right. So random number has a great application. So today's part of the things we're going to discuss is this random number. How do we generate a random number? So at last, the objective will be describe the purpose and the uses of random numbers in Java programming. We identify the method of the random class that obtain random numbers. Since we are talking about random number and we say random is a class, so if it is a class, then we expect to have a lot of methods.
Okay.
We have a lot of So there are a lot of methods associated to the random numbers. So that is why we say we identify those methods of the random number class. Obtain random numbers in a range of numbers. So how do we generate random number in a range of numbers? Let's say from 1 to 20 or 50 to 100, like that. So you can specify the beginning and the end. And now within the lower and that upper bounds, number can be generated, and you can use it for any kind of simulation purpose. Then we understand the purpose of the random number seed. That is specifying to what extent does it need to generate. So what is the purpose now? We start with the purpose of generating random number, which we say a software application often needs to perform a task based on some random obtained value. That is in the case of the software application to some extent. Let's say you want to do a gaming. Yes, I can say, okay, maybe you can guess a number. And then we try and then see what number will generate. If the number that generated is the same as what you guess, then we can say you have won the game. So things like that. So because there is no any biasness, it does not mean when I say 1, then it's not going to give 1. No, whatever is generated there will be either I've got it the same as what the system generated or not. So we use it in gaming and we use it in many applications where there is need to generate some unbiased numbers. So several applications need generation of random numbers, especially in the statistical concept, because random number is unbiased. So you can use it in generating numbers like, let's say in queuing system, or in many applications, which I don't want to go into that since we're not looking at the application of or in the statistical aspect, but just to let you know that it has a great application, which if you have the time, you can also explore. But nevertheless, by the time you understand what is random number and how it is being used, so whenever there is any kind of a similar situation, all you need just to reflect back and, okay, now most likely I can use this. I can write a program that will handle this because it's a random number generation. And how it's going to be handled by the Java programming is what we're going to look at. So let's look at some applications that use random number generation. So thank God that we have some of the applications that I mentioned here. And like we mentioned, the gaming application. So a card game application needs to shuffle a deck of cards randomly and then randomly distribute the card to the players, just like the way we take and then randomize something. So what if you want to automate that process? Rather than to take this card and then begin to shuffle them manually, then you can allow the system to do that, to randomize and put them in not a certain order. So that is a random. So the one that, if let's say we have a certain arrangement, whatever the arrangement it is, then the system will now reshuffle that and make maybe one to be in position 10 or 20 or 30 or 50. It depends on, it's just a reshuffling. So random number will help us achieve such. And also in a lottery application requires a randomly generated numbers that is based on an algorithm. So it's based on algorithm, whatever the algorithm, we just generate the random number, put it into that algorithm. That is to say the person wins if his number matches the random generated number, just like the one I've said. You win if the number you take matches the random generated number. Yes. So I say, okay, choose a number. This guy choose a number, this guy choose a number, then we'll generate. And if we generate, whoever lucky to get that, we say, yes, you win the game. So far in the previous lessons, we saw that Java comes with a variety of classes that support almost all basic application development features. Classes, there are a lot of classes that Java provides. If you remember, we use scanner. Those are classes as well. A lot of classes, like even the object and the rest, like the string also is a class. So given an example here, like string that provide capability for manipulating strings. Yes, this is a class that provide us now to be able to manipulate strings, which we have seen how we can get string, substring, index of car at a particular index. Remember that string processing, which is highly very important. We can be given text to process a text. Yes, and then from this text, we can search a particular keyword. We can find within a text, we can find a keyword or something and then replace. If you remember, we did that replace first and replace. So that will allow us to manipulate string. And what provide that is the string class. And then we have seen the scanner also that provide capability for obtaining info from the console. If you want to accept user input from the console, you use a scanner class because that is what provide that capability. Yes. So another important class in Java is the random class also, that is used to obtain random numbers. So if you want to generate random number, you use a random class. Just like you want to accept user input from console, you use scanner. You want to manipulate string, you use what? String class. Okay. So we use this random number to obtain random numbers. Of course, the class is located in java.util package. So it's the same package as that of the scanner. That means for us to make use of the random number, we need to import java.util package in our program. So this should be on the very first thing that we write in most cases, like we say import java.util. Just like the way we import scanner here. So rather than scanner, we just go down here, again, import the same, under the same package, .util.random, something like this. Yes. So this is for the random class, if you want to import. So when you import this random, you can create an instance of this random number based on the availability of the constructors we have for the random class. So this is what this is telling us now. We should going to use it in java.util package, which contains several methods that return randomly obtain integer, double, boolean, floats, and long type values. So it's not just integers that can be generated. Double, boolean also, floats, and long type can all be generated randomly. So remember, what all we are saying is just to say, let me generate a number, and the number should be random, should not be in a particular sequential order. Any number has an equal chance of being generated. It's unbiased. Yes. So it's just like I said, if you like want to conduct some simulation, that the simulation should be unbiased, then you should consider doing that by using a random number generator, which, if you can recall in your statistics, I'm sure they must have taught you this random number, because there are some functions that allow to use for such kind of situation like. So which is also generally accepted to conduct a research with a random number generation, because of its unbiasedness. So to import the random class from the java.util package, we have this java.util.random. So having importing this will allow us to create an object of this random class, which uses the new operator here, as usual, if you can recall how to create that. So this is the import statement that allow us to use the random class from the java.util package. And we create an instance now, create an instance of random class, which is called RND number. That's just the name of it, which can be RND, can be number, can be anything valid identifier. So doing this now, the next, after we know that we create the random number object, then we can now move on to see some of the available methods we can use in the random class. So those methods are basically, the first one, Boolean, is a Boolean, which returns, when you say next Boolean, will return the next Boolean, either true or false, true or false. It's just toggling between the true or false value. So which returns, this is a method in the random class, which returns a Boolean. That's why here we have the Boolean as a return type of the method. Then we have next int that returns the next integer. When you say next int, it returns the next integer, randomly generated. But then something in between the mean value and the maximum value of integer. Remember, we have the minimum value of integer and the maximum value. So by the time it exceeds that minimum, so it exceeds the maximum, then it means it's out of bound. If it is out of bound, that is an overflow. That means it's no longer going to be assigned to an integer, or you can use next int to get that integer value. So it takes the maximum. If you remember, we talked about the minimum and maximum value of an integer. Anything beyond that, we have to go for double. So if you are to go for higher precision, you take use of what? Next long. Next long will turn a long integer value, which is also had its own min and max. If you want to use the Rafa class and get the mean value of this. So you can, this is a constant. If you are, let's say now we go to our IDE, we write system.out.write line long.main value, will give us the minimum value of that, just like the integer. If you go by the integer, let's say, for instance, you come here and say system.out. Print line. Remember, we talk about the convention of naming variables. So for a constant, we make it capital letter. This is a convention. It's an advice for you to follow, but it's not that you must. But it's always good to stick to the convention, because it makes life easy for you and other programmers who are to collaborate with you when you follow the convention. So I can write here long dot main value. If you check here, is in fact the Eclipse will give us that something. So when you run, and then we see the maximum value of integer, the maximum. So anything beyond this cannot be assigned to a long. And if you want for an integer, you can say integer here. Then that also gives us the maximum value of integer. And if you want the mean, you can get the mean value. The minimum it can take, which is supposed to be negative something. So you see, negative base. Anything below this is no longer going to be an integer. Anything above positive of that value cannot be assigned to positive. So this is that. And if we say double, again, double, we can check to see what is the maximum double value it can take. You see, so this is it, up to raised to the power of, imagine this 4.9 exponential e raised to the power of, this e means exponential or raised to the power of minus 324. That is 324. Imagine decimal points, digits. Now, when you convert this now, imagine this will be 0.49 something point something up to 334 digits. Imagine, it's a long value. It's a very long one. So from the word double, it shows that yes, this is double. But if it is a float, remember we are using a wrapper class. Make sure you use a wrapper class. Wrapper class is the one with the capital. It starts with the capital, not small letter. Which you see them, their classes, and they are all in java.lang package. That's why we don't import them, and compiler will never complain, cannot find symbol, because they are in java.lang package. Just like this method now, if I click, you see some details about it. You see compare two strings lexicographically. The comparison is based on the Unicode value of each character in the string. The character sequence represented by blah, blah. These are some things we discussed, if you can recall, yesterday. So when you click and you highlight, it gives us some idea about, see, this string, blah, blah, blah. Yeah. So this is for the minimum value for the floats, which is not as precise as that of the double, because double has 324, but this has just minus 45, exponential minus 45, and this is 1.4. So we can, all we're saying, we can generate random numbers within this range of values. For the next plots will give us the decimal number between 0.0 included and 1.0 excluded. That means it's not going to include 1.0, but 0.0 can be included. But this one, if you generate, it gives you that's from main value and up to that max value. So when you take the double, the minimum decimal point number will give us what? The decimal number between 0.0 included and 1.0 excluded. But 1.0, what differentiates between this and this is the number of digits after decimal point. This has higher precision than this. That is just the difference, yeah. And remember, even the size of memory, the two are not occupying the same memory in computer. This requires 8 bytes of data or 64 bits, and this requires 4 bytes or 32 bits. So now, how do we now obtain this random number from the object of random number class? So this is the same as creating, as we have seen earlier, how to instantiate a random class. Next, we use this object now. Remember, if you always recall, use the name of the object or the name of the method. All these methods that we have mentioned here on the previous slide, all these mentioned, you can call them whenever you instantiate the object. So it means I can call next boolean, next int, next long, next float, next double on object of the random number here on this RND num. This is the name given. So you just say rnd.nextInt. So we're using one of the method nextInt, which return an integer basically. So whatever it returns, you can assign it to a variable of type integer. So here we call it random number, which is of type integer. Then if you want to see the number generated, you just print it out and say, this is the number generated. Okay. So now, if that means I want to try that random number, so I will just instantiate the object of the random number. I will just call it RND. In my own case here, I will make it as brief as possible. Then I will say random. Then, if I want to assign it to a number, I will just say number, for instance, equals to RND, the object, dot next int. Next, we now print it out, and it says system.out.print. .print or print line will say the number generated is number. So in this case now, it will start from the minimum integer minimum to integer maximum. Any number has an equal chance of being generated. So I don't know, if I now ask you what number, can you guess a number? You guess, and whatever you tell me, this is the number. But I can seed it. Seeding means I can decide to specify the lower and the upper bound. So nothing should go in between, we should go outside the seed. Yes, so later we're going to see, but as far as this is concerned, it can generate any number. And as you can see here, it's generating a negative one. And there is, when you generate again, you will see another different number. So this is possible. You see another different number. This is a random number generation. This is another random number. So each time you run, you will see a different value. Each time you run, you will see a different value. Each time you run, you see a different value. See, this is positive now. It's positive now. A positive number is generated. See, so now it's generating a positive, it's generating negative. So as you keep, each time you run, it's going to generate a different number. Each time you run, it's going to generate a different number. So I can make it like, let's say 1 to 50, then I'll call people, please, can you guess your number? Can you guess your number? We now try. Just like, you know, we used to throw a coin and said, okay, you choose your side, you choose your side, and then we throw a coin, and if it falls on, then like, so the same thing here. Can say, okay, can you guess a number? Can you guess a number? Then we have a gaming system here. We generate a number, and let's see what is going to be generated. This is unbiased. Cannot say, okay, because you choose one, then it's going to favor you to choose to bring one. No, it doesn't know anybody. It's unbiased. Any number can be generated, and every number has an equal chance of being generated. So it's unbiased. This is why it is accepted. But if it has biasness, then of course it won't be accepted as something that can be used in many applications. Okay, so we can generate any amount of numbers like this one. What this number generated will be different from what this number generated. Will be different from what this number generated. So we can have as many generated number as possible. All we are saying is this. Let's say now, instead of writing this on this, so I take it here, I use the object and just print it, rnd.next int. So instead of now printing on sentence, so I will just say I can generate any number here. So number 1 generated, number 2, number 3, number 4, number 5, number 6, number 7. Okay, so here now I can just like maybe number you and say, okay, you Ismail, choose a number. You, who else? Godwin, choose a number. Today we are just 2, including me making 3. It's interesting. Okay, so let me make it a game. Ismail, choose a number. Godwin, choose a number.
4, sir.
50.
Okay. Okay, I know it might be a bit anyway. Okay. I know none of you will get this because I know the kind of random numbers I choose is okay. But let me just run and let's see the numbers that are going to be generated. So you see, it's not even closer to that. Look at the random numbers generated. Remember that since we have not seeded it, if we have seeded it, then we will have just say, okay, let it be between 1 to 10, then we try. But remember that this 1 to 7, we just number them. If this one generated, we said this is not the first one. This is the second one, this is the third one, not because we are expecting to see 1, 2, 3, 4, 5, 6. No, that is not the case. So, and if I want this to be 10, let's say yeah, this is the seeding, which I intend not to write it until we go there, then we write it. But let me just write this. Write the 10, yeah. Okay, so anyway, let me try first, then I can now say 1 plus. But the 1 plus, I have to be very careful, otherwise the 1 will be concatenated with the string. Okay, so in this case now, can you see? Because I seed it to be what, 10? So nothing should go above 10 now. So if I now ask you, somebody choose 2, I can say, okay, somebody, and again, this one choose 2, this one choose 2. But if I want to make it like a serious game, all I need is just to generate 1 and say, okay, choose a number and you choose. So we now generate just a single number and let's see who got it. Okay, somebody say 4, so it's 4, something like. And then we run it again, choose a number. Somebody says 6. Oh, this is 6. Oh, great. We run it again, we see 4. We run it again, we see 9. So that's it. You keep running another different number, and it's the same thing, not because 9 can be repeatedly, can be 9, and the next generation can be 9, the next generation can be 9, can be 4, can be any. See, now we have 0. So that is it. So I believe random number is okay. Everybody understand what random number is. So you can make use of other methods, not necessarily going to be the integer. We can make it say next Boolean. Next Boolean. So next Boolean, we remove this. So when you generate next Boolean, you will see it says false. It says true. It says false. It says true, true, false, false. So you see, even this is generating in between the true and false, true and false. So if you make it to be a random number that's just say next long, then it will be generating a long value. Next long, you see, a very long integer value. Again, generate, we see another long integer value. Generate another one, next integer value. So like this random number of a thing, let's say you want to do a scratch card something, and you want to generate a random number that's okay. Anyway, it's easy. If I know the range of values, then I can generate a random number, and that's all. I am very sure that I can fall in and I can have the card already. So that might not be necessarily good idea to generate a random number within a range. But I can generate a number within the range of time. Imagine within milliseconds. So, and I'm probably reshuffle and do whatever necessary just to confuse it, so that not to be so easy for someone to guess. Something like so. It has a great application. Always same. It can be done with so many things. Yes. Okay. So move on. Then you can obtain the random number of double type by using the next double. So at least I've shown you, I said, okay, you can use the next long, next double, and the rest like. So exercise for you guys, please check and do it. So far we have generated a random number within a range of an integer data type. Sometimes you may want to restrict the range of numbers that can be generated. So that is the kind of restriction I'm talking about now. So where we want, we can say next int, then we specify the max value. And that's exactly what I did here, where I put 10 here. I say that is the max value. So meaning nothing can go above 10. Nothing can go above 10. So the argument determines the highest integer that can be obtained by the next int method. So you can also obtain the positive number from 0 included to a maximum excluded of your choice. So that means we can exclude and then start from 0 and generate the number. Example is this. 0 to 19. So 0 to 19, you can generate a random number from 0 to 19, saying this dot next integer, that is 20. So when you say 20, it means the 19 excluded. So if you want to include 19, you make it 21. You make it what? 20 or 21, or you add +1 here. So mean that once whatever number generated, you add 1 to it. That makes it to be random number 18 or 21. You can 20 inclusive. So you can generate a random number from 0 to 20 here. All is possible, just like I've demonstrated now. So this is the case now. To specify a range that starts with 1 and adds to the result of the next int method, for instance. To specify a range that starts with 1 and adds to the results of the next int method. So start from 1, meaning that instead of it to start from 0, you just say +1. So when you say +1, and then whatever it generates, so if it starts from 0, then you add 1 to it, then it's going to start from 1. So instead of it to start from 0. Yes. But remind you, the number here would be generated and then add 1. So to pick a number between 1 to 40, inclusive, really adds to the result. So that is this. So when you have this, that becomes inclusive. So meaning 1 and 40 will be included. So instead, 0 will be excluded, but 1 to 40 included. But take note that if you are to put it here, because this is a string, and you want to say this should start from, let's say, 40, and you want to add 1 here. So one thing that you have to be very careful, you need to bracket this. You need to bracket it. Otherwise, the concatenation will take precedence over addition. So this is something which is highly very important to take note. So this is 32, which is still within the range of 40. And generate again will give us this. Generate again will give us this. Generate again will give us a different value. So that's it. So if a range starts from a higher number than 1, subtract the starting number from the upper limit number and then add 1. Add the starting number to the result of the next int method. For example, to pick a number from 5 to 35 inclusively, that is from 5 to 35 inclusively, the upper limit will be what? 35 minus 5, that is the upper minus lower, then +1. That will give us what? 31. So, and 5 needs to be added to the result. So this is it now. So we now add 5 to it. So all you need to do just to say upper minus lower, then we now have this. So when you have it, the next to know what to add, remember that is the number you want to generate is between 5 to 35. 5 to 35. Yes. So to know what should be the upper limit, so that when it generates 5 will be added. Yes. Then should be 31. That is the upper. And then add the lower here. This is what this one. Subtract the starting number from the upper limit number and then add 1. So add 1. Add the starting number to the result of the next int methods. That is it. Okay. An example is this now. Okay, so now if this is clear, how can I generate a number, let's say from 7 to 20? What should be from 7 to 20? How can I write it? If suppose my R&D here will be what? Let's say next int. What will I write inside? What will I write? What is my X? What is my Y?
20 minus 7 is 13. Then we'll add 1, which is 14. For x to be 14.
And then what should be added here?
We'll add 7.
7, thank you. That's exactly how it is. Yes. Okay. So this is just another example. Enter a number between 1 to 10. So it's asking you now to guess using a scanner to ask you to guess a number between 1 to 10, and generate a number and compare with what you have guessed for. So this is the one, and it checks this 10. Then your number is this, and the winning number is this. So meaning it's going to say that the number you choose is this, and the number generated from the random is this. So you will see clearly that whether if this is the same as this, then means you got it right, isn't it? Yes. So that is what that is telling us. So I think we don't need to try this. This is quite simple and straightforward. So exercises for you guys. Take time, go through. So what is a seed of a random number? So you can achieve this by using a constant value called a seed. When you create an instance of random class, pass a constant integer to specify the seed. Pass a constant integer like this one now, 20 L, which makes it to belong. So that is the seed number. You can change the seed by calling the setSeed method. So that means this can be changed. Each time you pass the same seed, the same random sequence is returned when you pass the same seed. So that means I have 20L, if I change the 20L to something else, then it's still going to be the same. So all we are saying here is we have these random RND numbers as an object. If you want to change the seed, all we need to do just to call this RND numbers dot set seed. Then we now pass the seed, just like we have this 20L here. Remember, this is a constructor. Random number is a constructor. This is not a method. But if this is a constructor, you should recall our getters and setters. The setters are to set. The setters are to change the value of the instance variable, which probably the seed value. So when you call set, you are calling a setter to set what? Seed. And this is the seed now, which accepts it as the parameter to the random constructor. So this is now the example of that. We have this random and we specify the seed here, and then we say rnd.nextInt 1000, 1000, 1000. Sorry, 100, 100, 100. So we then see the number that will be generated within the range of these two, long 20. Then change seed to change the sequence by calling this rand.setSeed to 5L now, not longer 20L, 5L. Then generate. Then we'll see there something. So let's try this seed of 18. Let's say here we say 20L. We say 20L, and let's have this one, let's say 100. So let's generate. Then we see the number here generated. So now let's come here and say rnd.set seed to, let's say, 5L or any value. Instead of 20L, we change it to this. And then we specify, we come here and generate. Okay, so we run. We then see that this is 92. Yes, this is 92. Again, we run. We see this. Okay, so now going forward, changing the seed to change the sequence. This is it. Next is okay, setting seed to seed 20 produce previous sequence. Yes. So alternative to random class, we use mat.random. This is another option, which is in the java.lang package. You can use mat.random to read random number method. Returns a pseudo-random, that is double type, number greater than or equals to 0.0 and less than or equals to 1.0. So that's something in between. When this method is called, it creates a new pseudo-random number generator, the same as if you are using a random class, just like that of the random class. But this always return a double value. Enter the code from the slide notes below. Run the code several times to see how the result differs. So just that, I believe mat.random is not an issue. If you just write something like this, you just come here and say mat.random. So this generates a random number. You see, generate a random number between 0 points to 1.0. Nothing more than that. If you want to make it to be an integer, maybe let's say something between 1 to 1 something, so you can multiply by 100. So if you multiply by 100, then that will make it to be something like 86 rather than 0 point something. See? So for the application of making it to be 0 point something is when you want to generate a probability value. And you know probability is between 0 to 1. If it is 0, it means the probability is 0. The chance of something to occur, the chance of any event to occur is unlikely to occur is 0. Likely to occur is 1. Yes. So we know this probability of a thing. So that is the end of the random number generation. So we move to the next chapter. This is the random number generator. Okay, 4. So we now move to 4.5. Yes, question for, I think this is the random number generation.
You didn't show us how to format it.
Sorry?
You didn't show us how to format it, like the random number generated, like if you wanted to just do decimal places or a decimal place.
Sorry, I didn't get you.
Yes, generating the random number gives you a number of decimal points. So
yes.
If you want to get approximated to maybe 0.43 or 0.4, I mean that formatting.
Yes. So what I'm saying is with this random, when you use the random mat.random, not using the random class, you use the math. This math is a class, it's a static class in java.lang package. Look at it here. It's a static class which uses the random, which is a static method. So
I got it.
Sorry.
How do you round up numbers?
Okay, round up numbers. This the generator number, this particular one.
Yes, sir.
Yeah, this is why I said you can multiply. It depends on when you want to have 2 digits. You can say multiply by 100. When you multiply by 100, like this one and this number, when you multiply this by 100, it's going to be what? 43 points something. Yeah, because you multiply by 100, you shift this 1, 2, then so it will be returning 2-digit number. This is what I'm saying. So when you multiply by 100, then it always returns 2-digit number, points, then the decimal part. Okay?
Yes, I'm talking about the decimal point now, the floating area. You have 922 whatever. You might want to limit it to just 92.
Okay, so you just wrap this now. You just do this. Cast. Make it like this.
No, I want it doubled, but like it should be 61.92.
Oh,
without using the string format.
Okay, so I get you. You mean you want to round it off to something like, say, 61 point something like this, right?
Yes.
To 2 decimal places. Okay. Yeah, in that way, you have no option, but you have to use a C style, system.out.printf. Use printf, what you call print format. This is a C language style. So you now use this. And then you can now, let's say, for instance, the number generated, this is a string, I put it here. Then, and I use a placeholder. Since it's a double value, then I will now say %. This is what you call a placeholder. Then F means any number with a decimal, that's a floating point number. When I say floating point, I mean a number with decimal point. I don't mean floating point number. I mean number with decimal point. Then you now say .2f. The .2f means 2-digit after decimal point. Okay, no, sorry, %.2f, yes, %.2f. Then 2-digit after decimal point. This .2f means 2-digit after decimal point. 2-digit after decimal point. Then the next, I can now give what is the value, which is basically this. So I can now have this. So let me comment this guy and leave this. Okay, so now this will round it off to 2 decimal places. % is what indicates is a placeholder, meaning the value of this that will be, or what will be formatted by this format will be specified, but you have to use a comma to specify the value here. So this is what is going to be formatted based on what you have specified here. So what is expecting to see, this must be a double value. This must be a double value, that is 1, it's because of the F here. And .2 is saying round it off to 2 decimal places. But what indicates is a placeholder is this %, that whatever comes after should be formatted. That is what the % sign indicating. While the format specification will now follow. So this is it now. Let me run. Then you will see everything will be rounded to 2 decimal places. Let me comment this guy. The last one, remember the last one here. This is the last one we are talking about now. You see, 8.08. I've seen that. And you see 99 point what? 99.87. When you run it again, yeah, you see 77.53. Yeah. And if you want to format it, like in case of currency, money, you want to format it to have a comma separation. So let's say, for instance, if it gets to 1,000, let me add 0 here so that we have 3 digits. When we have 3 digits, if I have 1,000 or 7,000 or something, you know, for all this, we cannot just say comma for this kind of number. But when we have like this number, 1,000, then I can say comma, isn't it? In fact, hundreds are not 1,000 comma, so that means 4 digits. Indicate for 1,000. So I can just add, let's say, 1 more 0 here, so that if I come here, I can just say comma. This comma will put a comma separation in my output. So it's going to be formatted by 1,000, 100,000 something. You see 4,739 points this. You see, because of the comma, this comma that I put here, that is why it's formatted this and put a comma separation. So if you have, let's say, up to 1 million, it will say 100, comma 1,000,000, like that. So it's going to format it with that. So we use printf. You can use this to format it, unless if you want to use string.format. That is what you call string.format. So you can format using a string. You can say string dot.
It's a string that I know.
Okay, oh, it's okay. Okay, so you can use string.formats as well, and the same thing, everything follows. Just take this now, I take this, I put it here, all the same. So only that's when I come, I need to have str, then this, then when I come here, I can just put in the str. So I can remove the printf now. Just use the print line. So either way, it's the same. See? Okay. So that is this. Next, okay. Oh, this is the math class. This is the one we just did, 4.5. Oh, no, this is, okay. Do we need to worry about the math class? I think we can just move on, right? Do we need to talk about this? Math class is just allow us, it's a static class. Anyway, let's rush over it. It's just allow us to use some of the mathematical functions like absolute value, square roots, and the rest like. Okay, anyway, let's brush over it. So to understand the method of the math class, use the method of the math class to perform mathematical calculations. Yeah, we use the math class fields like, okay, so finding the maximum or minimum of two values, rounding values, logarithmic functions, square root, trigonometry functions. The math class contains method for performing mathematical calculations. So if we want, all we need, just come here, use the maths methods, use the math class, and then call all other methods you want. Let's say, for instance, I come here and I want to print out the square root of a number. Yeah, so I will use math.sqrt if I want to print the square root of a number. So square root of 4 is what? What is square root of 4? It's 2, right?
2, sir.
Okay. So yeah. You see, it gives us 2. But one thing you should understand, whenever, remember, even here, when you use the math.random, it generates the number in double value with decimal point. So every method you call in the math function, it always returns a double value. So rather than just seeing 2, it returns what? 2.0. So don't forget that math.random always return double value. So like this. When you check the square root of 64, so square root of 16 will give us 4.0, not 4. You see it here, 4.0. And then if I want, I can say absolute value of, what is the absolute value of 16? Absolute 16. Means what?
Give absolute us means the number without the sign.
Without negative, yes, without sign, thank you. So that will give us 16. Also, if you have negative 16 will give us what? Absolute value of minus 16 will give us what?
16.
To give 16. Okay, so that is just 16. What you mean by, yes, that's just what you mean by absolute value. Now, what of power? Power means what?
That's to raise something to the power of something.
Okay, so power means, let's say, 4 raised to the power of 2. So if you want to get power, you just say math.power raised to the power of 2. This will give us what?
4 times 4 is 16.
16. So it should be 16.0, right?
Yes, sir.
Yes. So that is just that. And then if you, let's say, for instance, the one that probably we may say is ceiling and something, let's say 3.4. Let's say ceil. We know ceil function?
Yeah, say we'll cap it.
Have you heard about ceiling before? Seal and flow function?
No, sir.
Yes, sir.
Okay. Okay, one said yes, someone said no. Okay. Now, the ceiling is saying return, remember, even from the word ceiling, it's saying return this largest integer, sorry, the smallest integer greater than the one given. The smallest integer, the smallest integer, but greater than the number given. So what is the number given? Remember the largest integer here, but smaller than the one given. What is given now? 3 point what?
3.4.
3.4.
So can you give me an integer, the smallest integer, but greater than 3.4? The smallest, but greater than 3.4. Integer. Remember, integer is no decimal point. 4. Thank you. So it doesn't, remember that this doesn't round off. Only just going to return a positive integer greater than the one given. Integer greater than the one given. So this is going to return 4. See? It returns 4. But like I said, always since it is a math function, it always returns a positive, a double value. So take note of that. So now let's say I have 5. Okay, so the definition is saying smallest integer greater than the one given, greater than or equals to the one given. But we are looking for integer greater than or equals to the one given. So what is given here now? 5. Isn't it? So can you give me the smallest integer greater than or equals to 5? Come on, just now. Smallest. Remember, we said smallest integer greater than or equals to. Okay, 5. Okay, so let's see.
5.
Okay, so that's excellent. So that's why I find my definition as a greater than or equals to. So don't just think as if it is already a number with decimal points, then you're also going to return a positive, an integer greater than that. So what if I make it 5.0? What should be? Because it's still an integer. So what if I have 5.1? What is the smallest integer but greater than 5.1? Greater than or equals to 5.1?
6.
So this will be 6.
6.
Thank you.
6.
Yes. So you see, it's simple, quite straightforward. And then there is what you call flow. Flow is the reverse of the seal now. So this one is saying, give us, rather than saying the smallest, give us the largest but smaller than 5.1, because there is no largest and greater than. Yes. So what give us the largest integer greater than or equals, sorry, less than or equals to 5.1, less than or equals to 5.1, not greater than, less than or equals to, that's a flow, should be less. But I can't, if I ask you, give me the smallest integer less than 5.1, can you give me that integer? Does that integer exist? Can you give me a number less than, that is less than the smallest one, less than 5.1? Can you give me that number? The smallest?
That's 5.
That should be 5.
No, I'm saying that I'm trying to refine my definition so that you should understand. Don't be confused whenever it's given to you like this kind of things, or to forget about the seal and flow. So from the definition, you realize that in some extent you might be contradicting yourself. Like in this case now, I asked you, give me the smallest integer less than 5.1. Just think about what I said now. Give me the smallest integer less than 5.1.
The smallest integer less than 5.1 can be into negative.
which doesn't have a limit. That's infinity, right?
It's not quite infinity because there's still a limit to what integer can get to.
Yeah, there's still limit for what integer can get to, but at least if you said give me the okay. Anyway, yeah.
Except
so
we are saying positive integer, maybe 1.
Okay, so yeah, you can say positive integer. Yes. But in the real sense, yeah, it's because of the memory. But in the real sense, when you look at to say, give me the smallest integer, because ideally an integer is infinite. Isn't it? Only that the capability of it, which can be long value. But integer is infinity. There is no limit, there is no lower limit, and there is no upper limit. Is that right?
Yes, sir.
Yeah, only that because of the memory, so we said this, but in the real sense, we know if I ask you give me a smallest integer that is less than 5.1, you said there are many integers. There are many integers. Only that when we look at it from the memory perspective, then we can now say, of course, it's not possible. But then all I'm saying, the definition is not correct. You cannot say, give me the smallest integer and greater than that, because such does not even exist. That's all I'm saying. So it could be like from negative infinity to positive infinity. It's because of the memory that we are saying integer, long, and the rest like. So, but if I refine it, I say, give me the largest integer, but less than 5.1.
That should be 5.
Less than or equals to 5.1.
That'll be 5.
Okay, 5. Okay, so that's it. Okay, so then this is SQRT. You can check we have seen the square roots. We have seen the POW. There are a lot of them, which few of them have been mentioned here. So let's check some of them, and you can check the documentation, and you find many of them. So such are like absolute value, ceiling, the one we have seen, the cause. But this is where now I think I may need to just explain to you on how to evaluate it. Then floor, which you have seen it, log, which is basically logarithm to base E now. And then we have log 10, and we have maximum value, we have minimum, we have POW, we have seen the POW, we have seen the random, we can round off, you can use round, you can use sine, you can use SQRT, not only this, many more. Yes, tan, sine inverse, cos inverse, like as sine, that means sine inverse, cos inverse, like that. So now to use, let me check if you want to compare two things like, for instance, let's say here I have math dots mean. Let's say I want to get mean of this. What is the minimum? 5 and 4. We know, obviously, this is quite simple, straightforward. So I think this is why I said no need that we need to waste much time on this. This just return a minimum value. For maximum, this return a maximum value from this. Yes, return a maximum value. So basically, these are the. Then move on to where I think we might just talk about is sine. Now remember, sine 30 in mathematics is what? It's supposed to be 0.5. 0.5. But is that right to make it 30? When we say sine 30, remember this is in radian. So this needs to be converted to degree. Because this will never give you 30. So it will never give you 0.5. You need to do something for it to get 0.5. So you see, it's giving us something. Because 30 is in radian, not in degree. So convert it to degree, we need to do a conversion. Remember, 1 pi, each pi now is equivalent to what? 180 degree, isn't it? Remember this? 1
2
pi
over
a
7,
radian.
which is
1 pi a radian is equivalent to 180 degree.
It's
This is a
180.
radian. Yes, 180 degree a radian. Then, since what is given to us is a radian, then 30 pi, 30. Remember, this pi, we're going to use a symbol pi, which is 3.142, as you mentioned. So then the 30 degree will give us x, because we don't know what is that value in degree. So all we need, just find x. Find x is same as multiplying 180 times 30 divided by pi, right? When we find x from this, it's the same as 180 times 30 divided by pi. So in that case, we just come here, multiply by 180, and then divided by what? Pi. So, but we have to make sure we bracket them properly. Then pi. So the pi itself, we can use mat.pi. Mat.pi is a constant, can give us the value of pi. So when we try this, it should give us 0.5, but not exactly 0.5. That may be because of some truncation, something closer. You see something closer to 0.5. No, does it correct? Okay, so that's something we miss. This is okay. Let me check here. This time this pi, which is pi is 180 degree, right, by x. Then when we find x here, this time this divided by this. Okay, yeah, this is 30. So this time this divided by phi, mat.pi. Mat.pi is then divided by pi, and this. So this should give us 0.5. Why? Or anything we miss? Anyway, let me try 60 here. So definitely, I know sine 30 is 0.5. Pi x pi equals to 180. As it's not like this is quite simple, times 30. Then we divide through by pi, then pi will come down here, mat.pi. So, which is basically pi here. So x is gone. Let me take it back. Let me come here. Let me put it here. Let's say double or sine 30 equals to 30 times 180 divided by mat.pi. So let this to be a double, then cut this detail. What am I seeing? Okay. Oh, maths dot sine 30. Math dot sine 30. So is that supposed to be minus 0. let's see cos 30. Okay, so I don't know what I miss because this is supposed to give us sine 30. Sine 30 is supposed to be 0.5, obviously. And mat.phi, which is 3.142. Yes. Okay, so we'll check that, please. I can't, but I believe this is correct. 180 pi, which is pi as pi, which is equivalent to half of the circle, which is 180. And we are looking for, oh, this is my mistake. Yeah, the 30, okay, yeah. I think this is my mistake. The 30 given is in degree. So I've swapped it. So this is supposed to be 30 here. Therefore, it's supposed to be 30 times pi. 30 times pi, then divided by 180. That is how it's supposed to be. So 30 times mat dot pi, then divided by 180. This is what is supposed to be. So sure, they should give us the, okay, yeah, this is cos. So if we change it to sine, then this is actually for cos 0.8660. So this is supposed to give us 0.5. Yes, so this is correct. I think it's in the process where I put this because this is in degree, not in radian. What is given to us is 30 degree. So therefore, this is per degree, and we find it in radian. Then we get that. Okay. So the same thing, we can change it to cos. You can change this to tan, and you will get all the values there. Yes. And if you want to see the value in a radian, but you have to convert it to something. So if you want to get inverse, you just say as sine inverse of 0.5. But as sine of 0.5, remember, is going to be a radian. So this needs to be converted to degree. Yes, this needs to be converted to degree. And to convert it to degree, which is the same as what we did earlier, you multiply by 180, and then you just come and divide by mat dot pi. So this should give us the results back times 180 divided by mat dot pi. Okay. Yeah, sorry. This is supposed to be like this bracket, and this, so this is supposed to be like this. And like this. Again, still not a number. No, how can it not be a number? So let me just put it here, 0.5, which is a radian, times 180 divided by mat dot phi. By going crazy. Why? Just a moment, let me kill this. Something came off to the screen. Let me terminate it. Why is my Eclipse? syntax go. So I destroy it. Okay, so let's get that, then we so here we are divided by 30. This is 0.5. And then assign using sign inverse. What will give us the sign of what will give us 0.5 if this is converted? So this first will also give us 130. So maybe the okay. No, this is pi. Now this is equals to 180 divided by max dots divided by max dots pi. It's still none. Okay.
I think instead of being 0.5 times mass dot pi, it should be.
It should be. Sorry.
When we're converting to radians, the thing is we multiply, the degree multiplies the pi, then the
yes.
validity.
Yes.
So since we've been given 30, I think the where you have 0.5 should be 30, then multiplied by mass dot pi divided by 180.
Okay. Is that okay? But remember that that is when you want to get the sign, not sign inverse.
No, it will not divide by, it will divide by 180.
No,
and then
why am I pressing? This thing is behaving, it starts coming again. Anyway, let me just stop it again and then Eclipse and it's okay. That one, let's just move. The conversion it's something which everybody can do. So you can try, please, any of these functions. Try to get that. So let's move on. This is square roots. We have seen the square roots. No issue. Get that. And this is again square roots. This is absolute value, and this is the minimum. Return the minimum. And this is the absolute value and all that. So this is what I said math function is. So these are the constants. The pi, we have seen it. And this math.e will give us the exponential. That is e raised to the power of 1. And e raised to the power of 1 is 2.71 something, exponential. So the pi value, so we can use it in many of our calculation, like let's say we want to get this area of circle. So we can get the math.pi times radius. If you remember, we did this in 2 and 2. Okay, so I think for anything, that's all. exercises for you to check. So can we enter another chapter, or what is our opinion on that? Yes, guys, do we enter another chapter or we stop here? Hello.
Hello, sir.
Yes, do we start this or we stop?
We can continue tomorrow.
Okay. So let's stop here, then continue tomorrow. So tomorrow we start the Boolean expression. Right. Okay. So any question from your side? It's okay. It's my pleasure. Any question?
No question from me, sir.
Okay.
No question, sir.
If there's no, okay, so thank you. Till we continue tomorrow. Yeah.
All right, sir. Thank you very much, sir.